Hey guys, I wanted to actually show you one of the most important tool that I use sometimes in order to do simple regression modeling. And this is the tool from SAS Institute. It's called JMP. It's a very interactive tool to use. So I'm just going to show you a quick version of like how I use it, and show you like simple regression, linear regression that I create out of this. So if you look at it from this, the interface itself, you can see that it has these columns indicator in terms of like whether it's a continuous variable, ordinary variable, or a nominal variable. All of these things will be shown on your left hand side. The icon over here, I don't know whether you can zoom in or not, means you can see that most of the the item over here, if you look at it from from the icon standpoint, these indicate actually that these are categorical or continuous. So if you see a triangle, a right angle triangle, that's a continuous variable. Okay, when you see some sort of a histogram, that shows that it's an ordinal or a nominal variable. Now you can see it in the data set itself. Like if I look at the the item weight, that's a continuous variable, right? So you have a lot of these values that are in digits, so that's basically a continuous variable. Whereas if you look at the item fat content or item type, these are all categorical, right? So you have dairy, soft drink, meat, fruits and vegetables. So all of these are categorical variable. Now, the great thing about JMP is that you can actually do graph. You click on graph and then go to graph builder. This will pop up this the window, the graph builder window, which actually gives you a very good indication of like how do you look at the interaction between the variables, right? So if let's say if I'm looking at the item outlet sales. So item outlet sales is probably going to be my y variable, because that is what I'm actually trying to understand, or trying to predict, what could be the outlet sales value. So I can look at it based on, let's say, item type. Okay, so if I click that on the x-axis, it shows me the histogram, like how the outlet sales is changing based on different item type, whether whether it's a breakfast, canned products, dairy products, frozen food products, fruits and vegetables. So you can see that kind of a box plot in terms of like how these are distributed across different categories. Okay, you can also look at let's say the outlet location type, and you can just drag it over here and see like tier 1, tier 2, and tier 3 location, and see how the outlet sales are distributed. Okay, so in tier 3 you see that some of the items are much more heavily heavy sales going on the tier 3 side, right? You can also look at the overall relationship between the outlet item sales and the MRP value. So you can see that that's kind of like a linear relationship. But one of the things that you will note that if you see this graph is that a lot of the values are basically kind of they are basically logged into a very small value. So a lot of them are actually close to zero, and then there are a lot of them that goes above. So you see that in the FMCG market, like most of the items are not going to be very expensive, right? A lot of them are actually skewed towards the zero value. So when you look at this type of graph, you need to understand that whenever you're looking at the y variable, which is the item outlet sales, it may not be distributed in a way that you that you want to put them directly into the y variable and try to calculate what all are the predictors or the features dependent on this outlet sales, just because of the fact that a lot of the values are going to be close to zero. Okay, close to zero, so it's not really distributed. Even if you standardize it, I think it's not going to show a good distribution. So let me show you like what I mean by that. So if I go over to analyze and then do distribution, and I'm gonna click on, let's say, item weight, visibility, MRP, and the outlet sales. So these are probably some of these continuous variables that I can look at the distribution of, right? So when I look at that, I see the item weight basically has some sort of like a, you know, uniform distribution, right? It's basically, again, it changes value, but they are equally distributed across different weights. So it's not that there's so much of variation. Whereas in the visibility side, a lot of them have very low visibility. Okay, some of them are very high visibility, like the the grocery, the produce section of the grocery store. They usually have a very high visibility just because of the fact they're all laid around. Customers go in, they look at it, they can instantly see what is there, which one is fresh. They can feel it, right? So the visibility is much higher for those type of items. Whereas for other items like frozen foods, things that are kept really at the back of the shelf items, there's not much visibility. So you see a lot of them actually fall into that in major superstores, but a lot of them do have some visibility. But you can see the outlet sales over here, so that shows like it has kind of a skewness, right? So that's what I was talking about. Like a lot of the values are basically lying at the at the range of 0. Okay, and then it goes up and up and up, and then you see some of the items that are very high. Probably, I don't know, but that's probably like some electronic items that might be selling in the superstore that might have a very high value, but most of them do fall into this. So whenever you're trying to do a linear regression, you need to make sure that you understand these distribution for each of the variables that you're looking at, correct? So this kind of gives you a very good visual representation of what you have. Plus it also shows you if there are outliers in your data set or not. But the purposes of demonstration, I'm not going to go into the details of like how do you treat all of these stuff. This is just a quick video to showcase how you use this tool. So once you have these type of analysis done, like in terms of looking at the distribution and seeing how they look, what you can do is you can go into the outlet sales, and I'm going to create a new variable for this item outlet sales called the log item outlet sales. Okay, and the way that I'm gonna utilize a formula option in JMP is to create a log value of the item sales. So let's say if I'm gonna go in and look at whether it comes into sorry. So I'm looking at the log. So you have so many different functions that you can use in JMP. It gives you an indication of like what exactly can you operate on. You can use time, date time. You can use statistical. You can use some sort of probability if you want. So a lot of these options are available to you, right? But if you want to look at let's say I'm just trying to figure out where the log is. You can also create again lag variables too. So yeah, so it's in the transcendel. So you can choose log of 10 or log of e. I usually go with log of 10. So if I log of 10 and I'm looking at what variable, I'm looking at the item outlet sales. So this will create the value. You can see that the value just popped up over here. So this will create the log scale value. Okay, so when you look at the log scale value, and then now I'm going to look at the graph builder and try to see like how the distribution takes place, then you'll realize that there is a difference here. So if I see y variable as the log item outlet sales and the item MRP, now you can see that there is the distribution is much better, right? It's not skewed all towards the downside of the 0 to 10 value where most of the products are going to be sold, but now I'm just pushing it up and then making it much more linear in correlation. so the fit is going to be much better. So you have to again play initially to understand how the the values are distributed in your data set before you try to model them. Okay, so it looks much better here. Okay, now if I even go in and see let's say different item type and see how they're distributed, now you can see that a lot of the values are kind of again fluctuating. That means there's a variation. So that means there's a lot of information about the item type versus the log item outlet sales. Okay, so that gives you also a very good indication of like how these variables can influence the outlet sales. Okay, so I'm gonna do a quick regression modeling here, but before I do the regression I need to do a quick validation creation of quick validation column to understand like how you're going to be splitting the data from train and the validation, and then how you fit the data, right? So in order to do that, you go to call and then utilities. So in this case, I'm just looking at it says make sorry modern modeling utilities. So if you go to modeling utilities, you'll get an option of make validation column. So if you click on that, you will see the make validation option. Once you have that, you can give the percentage in terms of like how much you want to put it in validation. So I'll put it as 70%, and then on training I'll put it as 70%, and validation I put it as 30% of the data set, and it's going to be purely random. And once I have that, you can see that there's going to be a new column that is being created over here. So if you look at it over here, you can see that the validation column is created where the split has happened between validation and the training. Okay, so now what I'm going to do is I'm going to quickly build the model. Okay, just to show you like what all are the options are available for me to build a model in JMP. Okay, so if I go in over here to analyze, okay, and I click on fit model, okay, it'll give me this option. Okay, this option is going to tell you what y variable you're trying to predict. Okay, so this is going to be log of the item sales. Okay, and what all are the independent variables or predictors that you're trying to get into the model. Okay, so in our case we're going to use all the continuous variables, okay, except the outlet establishment here. So I'm not going to touch that because it's not properly set up, but all the other variables I will. Okay, and then the other thing that you can do is you can also use categorical variables if you want. JMP doesn't really need to have dummy variables created to do the analysis, because JMP evaluates whether that particular variable is categorical or not, and it actually provides a good insight. It can split the data of those categorical variable into interaction variables and see which variable, what type of categorical variables might be important in the data set. So I'm going to use just one of them, item type. Okay, and I'm going to use the rest of the other ones, which is the weight, visibility, and the MRP. Okay, and then on the validation side, I'm going to put that into the validation option. Now the other thing that you will notice that there's personality over here, right? So in personality, like you want to choose what type of personality you want to use in order to run the model. So usually it's a standard least square, but you can use stepwise, you can use generalized regression, mixed model, and COVA, log linear variance. Okay, so in terms of using the personality, I go with stepwise. This is kind of a standard way of looking at how the model performs. So I'm going to use stepwise. Stepwise regression is going to actually run the model for you based on certain indicator, and it will give you kind of comparison between the validation and the test data set. Okay, I'm going to keep this dialog open, and then I'm going to click on run. Okay, so once you click on run, you will see the something like this pop up. This is a new window that pops up. So it tells you like what is the stopping criteria that you want to use, whether it's a max validation R square or you want to do p-value threshold. P-value threshold, you can define p-value threshold for entering and exiting, but I'll mostly of the time when you do a validation, you use the max validation R square. Okay, there's a AIC or BIC. Those are the also another option that you can use in order to create a stopping rule. The other thing you will notice is that it has already shown you what is the SSE DFE right now, just to without any kind of features added into the model. And also you can see like all of the different parameters that's been added up. So you can see that weight, visibility, MRP was already there. But now once you added a item, item had a lot of different categories, right? But you can see all the interaction is being evaluated by JMP, and it's been added into the parameters. So you don't have to really create a dummy variable to do that. You can see that all of these different parameters are automatically added. It makes modeling a little bit more I would say difficult to interpret, just because of the fact that it does its own parameter evaluation and checking. If you want to make it simplified, make it would be easier for you to understand, I would recommend you to create dummy variables and play with it. But if you don't, you can just directly put in and see how it works. So once you have all of this, what you can do is just you can click on go. Okay, so when you click on go, JMP is automatically running optimization to fit the model to see which one is the better indicator. So you can see on the step history all of the steps that JMP took, like it entered MRP, it entered visibility, it entered the item type, all of that stuff, right? So as it enters the variable, it looks at the R square value. Okay, so the validation R square versus what is the actual. So the validation R square is pretty low over here right now, which is 0.34. Okay, but it checks all of that stuff and it tries to figure out what is the best validation R square. Okay, and it fits the model. So when you click on run the model, it runs the model. It shows you the output in terms of those two variables that it actually chose, the MRP and the visibility. Okay, those are the two variables that it chose. In the model you can see the adjusted R square and the and the fit of the model. If you want to get the equation, you can use something called estimates and show prediction expression. So it shows you the equation of the linear regression that is being created. Okay, so in this case you can see that with the intercept you have the equation being created. Now this is just a simplified version of you just running through the steps and seeing how JMP actually creates model, but there's a lot of iteration that you have to do. Okay, I'm not going to go into the detail about that in this video, but I will have some other video which will go into the details of how you actually run these different models and come up with the best optimal model, because the R square value in this model is very low. This probably is not the best fit model. But the steps are going to be almost the same in terms of dealing with different types of data set. Hopefully you like this video. I'll see you in the next one.